Hey everyone, welcome back to Math with Vanch. I'm Vanch and I'll be teaching you math, obviously. In the last video, we defined what a derivative was, and we found that it was basically just a slope of a graph at a particular point. Now in this video, we will be finding a much easier way to find the derivative of any function. Like in the last video, we had to do all that work and use limits and all of that just to find the derivative of a function, but in this video, I will show you a much easier way, and that is called the power rule. So if you're ready, I am too. Let's get started. Now, it's important to note that power rule only works with polynomials or functions that have a degree. So basically, like functions like x cubed, x, that's just 2, x cubed, x squared, x to the fifth, even like square root x, because square root x is basically just x to the one half, right? X to the 1/2, and even negative exponents too. So you can have like x to the -3, x to the -5. You can have decimals too in the exponent. Basically, x to any power is when you can use the power rule, which is again why it's called the power rule. So the power rule in simple terms. So suppose we had f of x equals a times x to the n power. Now this is a general term where a is the coefficient, and n is our exponent. Okay? So a in this case can be any constant, and n could also be any constant, any number really. So if we want to take the derivative of that, now derivative notation can be written in multiple ways. We can write derivative notation as d over dx of f of x, and we put f of x in little brackets like that. We can also write the derivative notation as f with a little apostrophe in front of it and x, like that. We call this f prime of x, just as an easier way to say it. So both of these ways are ways to show that you're taking the derivative of a function. So anyways, so in this case, this would be equal to, so what we do in power rule, we basically just bring this exponent down and then subtract it by 1. What do I mean by that? So the derivative of this function right here would literally just be a times n times x to the n minus 1. I know that doesn't really look like much right now, but let's do an actual example and I'll show you what I mean. So I'll write the power rule in the corner so we know what we're doing. So we have f of x equals a to the x, a times x to the n, and f prime of x equals a n times x to the n minus 1. So let's look at an example. So suppose we had f of x equals x to the fifth, or yeah, x to the fifth, right? So literally what we would do, in this case, our a is 1, because you can pretend there's an imaginary 1 right here because it's multiplying by 1, which basically makes it go away. And our n would be 5 because it's in the exponent, right? So this means that the derivative of f of x would be a times n, so 1 times 5, which is just 5, times x to the n minus 1. Now what's n minus 1? N minus 1 is just 4, because n is 5. That's it. That's literally it. So the derivative of x to the fifth is 5x to the fourth. And look how easy power rule made that. So if we wanted to find like the derivative of x to the fifth at, suppose, the point 3, right, when x equals 3, so then when so we'll have f prime of 3 equals 5 times 3 to the fourth, which is 5 times 81, which is, I think, 405. That's it. So what does 405 actually mean? 405 means that is the slope of the function when x equals 3. That means it's increasing by 405 units of y per unit of x at that instantaneous point. So let's look at another example. It's really just this easy. So we'll do f of x equals, we'll say 3x to the 9th, right? So in this case, what would f prime of x be? So f prime of x would equal, so what is our a in this case? Our a in this case would be 3, right? Because that's the coefficient right here. And then our n would be 9, because that's what's in the exponent. So our n equals 9. So to find the derivative of this function, we would just do a times n, so 3 times 9, which is 27, x, and then subtract 1 from 9, so 8. And that is the derivative of this function for every x. That was pretty easy, right? So yeah, that's basically the power rule. It makes finding derivatives so much easier, and you use it throughout calculus all the time. I love the power rule, honestly. It's probably my favorite rule. It just makes taking the derivative so much easier for any power. Yeah, and you can have this with multiple, like if you have, suppose, f of x equals like x cubed plus x squared. Now the cool thing about this, you can kind of break this up into two. So you can kind of, in this case, take the derivative of this part and then add it to the derivative of this part. So this would be the same thing as saying, like, what is the derivative of x cubed? Well, that would just, so we would bring the exponent down, so 3, and then subtract 1 from the exponent, so x squared. And then we would add that to whatever the derivative of x squared is. So we would bring the exponent down, 2, and then subtract 1. So we would have 1 in the exponent, and x to the 1 power is just x. So 2x. And there's the derivative. So you can do this with adding and subtracting, but you can't do it with multiplying and dividing yet. We'll get to that in a different video. But yeah, that's the power rule. So that is going to be all for today. That was a pretty easy lesson, I'd say, for today, because power rule is so cool. I love it so much because it really just makes taking the derivative of any function so much easier, as long as you have x to some power, and it really doesn't matter. Although I should do one more example, I feel like, and this time just with a decimal. So we can do something like f of x equals square root x. Let's do that, right? So we know square root x is basically the same thing as x to the 1/2 power, right? So if we want to take the derivative of this, we would just do f prime of x, and then we would bring this exponent down, so we would have 1/2. And then we would subtract 1 from the exponent. Now what's 1/2 minus 1? That would just be negative 1/2. So we would have x to the negative 1/2. And often a lot of people write this as like 1/2 times, because if you have a negative exponent, that just brings it down. So it would be 1 over x to the 1/2. and x to the 1/2 is just square root x. So 1/2 times 1 over square root x, and you can just multiply these two together to get 1 over 2 square root x. You don't have to do all that. This is a perfectly acceptable answer, but if you just want to simplify it a bit more, it's not really simplifying, but I don't know, if you just want to put it back into radical form, then that's how you would do it. But this is a perfectly acceptable answer. But yeah, that would be it for this video, and I hope you enjoyed, and I will see you for the next one. Bye bye.